Graphs of equations, this is a relation, is the equation true when the values for x and y are substituted in the equation. For example, the point 310 satisfies the equation y equals x squared plus 1 because 10 equals 3 squared plus 1, but the point 13 does not, right? Because if we plug in 3 for y and 1 for x, well, 3 does not usually equal 1 squared plus 1. So the graph of the equation in x and y is a set of all points in the coordinate plane that satisfy the equation. Right? Sometimes our graph crosses the x-axis or y-axis or both, and those are our intercepts. The x-coordinates of the points where a graph intersects the x-axis are called the x-intercepts of the graph, and are obtained by setting y equal to 0 in the equation of the graph. The y-coordinates of the points where a graph intersects the y-axis are called the y-intercepts of the graph, and are obtained by setting x equals 0 in the equation of the graph. All right, so x-intercepts, the x-coordinates of points where the graph of an equation intersects the x-axis. How to find them? You set y equal to 0 and solve for x. Where they are on the graph? They are where the graph crosses the x-axis. So these would be the x-intercepts. All right, so A, B, C. Points A, B, and C are x-intercepts. That thing is a comma. Let's see if I can make it look better. There. Y-intercepts is the y-coordinates of the points where the graph of an equation intersects the y-axis. So you're going to set x equal to 0 and solve for y. This one has two y-intercepts, D and E. Right? So points D and E are y-intercepts. Now, if we were talking about the graph of a function, right, the first one is a function, the second one is not. In terms of x-intercepts, a function can have 0. We can think of parabolas, right, that don't cross the x-axis, where the vertex is above the x-axis and it's concave up, or below the x-axis and concave down. So a function can have 0, 1, or more x-intercepts. In terms of y-intercept, a function can have 0 or 1 y-intercept. There are some graphs that have no y-intercepts. If you remember back to the graphs of log functions, they don't have to have a y-intercept unless they're shifted right and left. But a function cannot have more than one y-intercept because otherwise it will fail the vertical line test. So this is not a function because this, if I draw a line, look at, I'm intersecting the graph twice. So that's not a function. But that's okay. Nobody said it had to be a function. Matter of fact, we're going to graph today some non-functions, and those can I get rid of that? I guess not. Those non-functions are circles. Circles are not functions because they do not pass the vertical line test. Let's get rid of that. Cut, not clone. I don't need more of them. All right, so finding intercepts. Find the x and y intercepts of the graph of the equation y equals x squared minus 2. All right, very easy to find your x and y intercepts, no matter what the equation is. All right, so x-intercept, especially the y-intercept. X-intercept, set y equal to 0 and solve. So we have 0 equals x squared minus 2. Since we have no x term, why don't we get x by itself and take a square root of both sides? So let's add 2 to both sides. 2 equals x squared. And then take the positive and negative. This one is going to have two solutions because it is an x squared. Right? The number of solutions for a polynomial matches the exponent. So we'll take the square root of both sides, and that means that our x-intercepts are positive and negative square root of 2. So that means our graph here has two x-intercepts. We have positive square root of 2, 0, and negative square root of 2, 0. How about the y-intercept? All right, now we want to set x equal to 0 and solve. And actually, in this case, since y is isolated, we're really just going to simplify. It's not really a solve. All right, so this would be y equals 0 squared minus 2, so y is negative 2. And actually, it's really easy to figure out the y-intercepts from the graph, right, because they're what's left over that's not an x, right? So it's because x squared is going to go to 0, my y-intercept has to be what's left over, and that's the negative 2. So the y-intercept is 0, negative 2. And that's all there is to that. Not too bad finding x and y intercepts. And I'm going to pause here and let you find some x and y intercepts.